Hello everyone, welcome to our fourth lecture in Introduction to CFD. This time around, what we're gonna see are a few new things. We're gonna set up for the first time a transient problem, so a problem that is time dependent. Up until now we have been working only with steady state simulations, so now we're gonna be doing this thing a little bit different. We're also going to use an opening type boundary condition, which I have already discussed before and showed you, but we have never used. But this time around we're going to be using one. We're also going to be setting up multiple configurations in CFX-Pre. What this means is we're going to be setting up two simulations this time. And the first one is going to be, the results of the first one are going to be used as the initial values for the second one. Okay, we're also going to create an additional variable in CFX-Pre, and we're also going to be seeing some new things in CFD post. Okay, so let's take a look at the problem that we're going to be discussing today. The problem is basically a chimney that is going to be spewing smoke into the air, and what we have here is a 10-meter radius domain, because we need to set up a boundary to where we're going to analyze the smoke. Okay, so this could be larger or smaller depending on your problem, but this time we're going to be using a 10-meter radius. So we're going to have a 10-meter radius domain. Here's our chimney, which is going to be spewing smoke varying from 0.01 meters per second to 0.2 meters per second. So the speed at which the smoke comes out of the chimney is also going to change. And we're going to have wind in this problem as well. The wind is going to come from this direction, from left to right, at 1 meters per second. This is going to be clearer when you see the whole domain in the software. Okay, so let's begin. This right here is going to be the file that I'm going to send you. So what you do, you extract the files here and make sure you have circvent mesh.gtm, especially this one. Okay, this is going to be used only if you want to skip some steps, which I don't want you to. So make sure you have the mesh file right here, which is the circvent mesh.gtm. Right, so let's open CFX. We're going to be using CFX in its standalone mode, again, not in the workbench mode. So open like this. Now, always remember, choose your working directory appropriate. This is going to make your life much easier throughout the simulation. So the one that I'm going to choose is the folder where I have these files right here. So it's going to be, in my case, CFX tutorial 6 flow from a circle event R17.0. Okay? With this being done, we just click CFX Pre. Okay? And wait for it to open. There you go. Now let's create a new case. We're going to be using the general option. Again, the first time we use the software, we use the quick setup. The quick setup limits our choices a lot. So most of the time you want to use the general setup. Okay? I would say the quick setup is almost only for teaching purposes. Okay? So let's choose the general option. There you go. Now let's save our case. I'm gonna save it as circvent. And now let's open our mesh. Okay, so click File, Import, Mesh, and choose circvent.gtm. So there you go. We have our chimney here. We have two walls. So basically, one wall is gonna be used as the inlet for the wind to come in, And the second one is going to be the opening. Why are we choosing opening? Because this time around, we don't know if the wind is only going out of the wall, because we're dealing with the air, the free air. It's much harder to predict where the flow of the fluid is gonna go to. So this time around, we're gonna use an opening boundary condition, okay? So let's also put this in the best camera. So just click the right button, go to predefined camera, and select isometric view Z up. Okay, this is gonna be the best camera to view everything that we want, right? So in this tutorial, we're gonna create an additional variable, which is basically, for this case, is a non-reacting scalar component, okay? So we're gonna create it by going to the insert bar, you go to expressions, functions, and variable, and you click additional variable, or you can come here in additional variable, right click it, insert additional variable, okay? Set the name to smoke. Change the variable from specific to volumetric, and basically we're going to use a concentration unit. So it's gonna be mass under volume. In this case, it's gonna be kilograms to under meter cubic. Okay? Remember, you need to write it like this. If you write it like this, the software is not going to be able to read it, okay? So write it like this, okay? Then you can click OK, and you can see that our additional variable has already been created, all right? Now we're going to set up our steady state simulation. The steady state simulation results are the ones that are going to be used as the starting point for the transient simulation, okay? The time-dependent simulation, all right? So let's change the name from flow analysis 1 to steady states analysis, okay? So we know that everything under here is going to be referring to the steady state analysis, okay? Very well, let's now create our domain. We can go to insert domain, or we can simply click here, okay? This is gonna be our domain. We're gonna name it the circ vent, all right? Very well, now we're gonna need to set up everything for this domain, including where it's gonna be located, okay? So the first thing that we're gonna choose is the location. So we change the location to B1, P3, and make sure that everything is highlighted here, okay? And you can click OK. Now we're gonna something worth noting is that for the first time as well, we're not gonna be dealing with water here. We're gonna be dealing with air and the additional smoke variable that we created, okay? Very well, so make sure that the material is there at 25 Celsius, okay? Here is gonna be the default, so we are dealing with a fluid, okay? We're not dealing with a immersed solid or a porous domain. We are dealing with a fluid, so this is the correct one. The reference pressure, instead of 1 atm, we're gonna be using 0. And now we can go to our fluid models, okay? The heat transfer option we're gonna change to none, because the temperature here is not important. We're not dealing with anything related to temperature. And make sure that this option right here is selected. This option only shows up because we created the additional variable smoke, okay? So make sure this one is selected. Now check kinematic diffusivity and type 1.0 times E minus 5. Okay, so this is basically 10 to the minus 5 meters squared per second. And this is the kinematic diffusivity for smoke in the air. Okay, so this value is coming from the knowledge that we have as to how smoke disperses in the air. Okay, so click OK, and we're done here. Now we're going to create some boundary conditions. Okay, for this example we have external flow. Okay, and since fluid is flowing over an object and not through an enclosed one, such as a pipe, for example, that we saw in our first two, in our second and third lecture, we had water flowing through a pipe and reaching the mixer. Now we have a flow going around an object, going over an object. Okay, and in external flow problems, some inlets will be made sufficiently large so that they do not affect the CFD simulation. Okay, so this is why you're gonna see that our inlet is this whole wall right here. It's a very large inlet, so that it doesn't affect the CFD simulation. Okay, however, the length scale values produced by the default intensity and the autocompute length scale that we used before in our lectures are usually options for turbulence based on the inlet size. Okay, and they are appropriate for internal flow problems, particularly cylindrical pipes. So in general, you need to set the turbulence intensity and length scale explicitly for large inlets. Okay, especially external flow problems such as this one. So if you don't know the value for the length scale, you can use the length scale based on a typical length of the object, okay, which the fluid is flowing. So in this case, we're gonna choose a turbulence length scale that is 1/10 of the diameter of the vent. Okay, you're gonna understand this better when I show you where these values are gonna be put on. All right, so now let's create our boundary condition. Let's go here and set up boundary, and we're gonna change the name to wind. So this is gonna be the wind boundary condition, and it's set up right here. Okay, so the wind is gonna come from here at 1 meters per second. All right, and it's gonna come from all the wall. All right, so make sure that wind is set up here, and let's go change the values here. Instead of normal speed, we're gonna use Cartesian velocity components. So the component for u is gonna be 1, for v 0, and for w 0 as well. So we only have wind coming at the u direction, so which is basically the x1. So we have wind coming only from this direction right here, the x direction. All right, very well. Now change the turbulence option to intensity and length scale, and change the value of eddy length scale to 0.25 meters. Oops, 0.25 meters. Okay, so we know that the radius of the length scale of the inlet, the length scale of the chimney is 2.5 meters. So this is why we're using 1/10 of it in our eddy length scale. Okay, so remember, if you don't know this value, you pick up the value of the object that the fluid is flowing over, and you can choose a value that, for example, in this case is 1/10. Okay, very well. Now let's choose the value of smoke in the wall, in the inlet wall, which is going to be 0, right? We only have smoke coming out of the chimney, so in the wall is going to be 0. All right, so you can click OK, and now you can see that the inlet wall is already set up. All right, Do not worry that the arrows are only showing at the borders of it. It's just a representation matter from the software, but know that the wind is gonna come from all the wall, okay? Not only from the borders. So let's rearrange our camera. Very well. Now, let's create our chimney. No, first let's create the rest of the wall here, which is gonna be our opening condition, okay? So click boundary. I'm gonna name it atmosphere. All right. So basically, the wind is passing through the atmosphere. All right. This time it's not gonna be an inlet. It's not gonna be an outlet. It's gonna be an opening boundary condition, which allows flow to go in both directions. All right. So select opening. Make sure the location is set to atmosphere. Go to boundary details, make sure that opening pressure and dim is selected. Type 0 Pascal to the relative pressure. Change the turbulence to intensity and length scale. The length scale is the same, 0.25, and the value is still 0. Okay, why? Because in the beginning of the simulation, we only have smoke coming out of the chimney, all right? And remember, this is the steady state simulation. In the steady state simulation, we're not gonna have smoke. The smoke is gonna only appear in the transient simulation because it is time dependent, all right? So now let's create the boundary condition for the chimney. All right, so let's change here to the vent, the air vent right here. It is an inlet condition. The normal speed is gonna be 0.01, so basically we have air coming out of the chimney at normal to this face right here, and change the turbulence option to intensity and additive viscosity ratio. Pay attention that it's different from the previous two. The previous two we were using intensity and length scale. Now we're using intensity and additive viscosity ratio, okay? And leave it at 10 here. The value for smoke is still 0. So we do have fluid coming out of the chimney, but it's not smoke yet. It's just air, all right? And it's air at a very slow velocity, all right? It's 0.01 meters per second. So type OK. Now let's take a look at our global initialization values, the initialization values for the simulation. Just check that everything is set up as is here, because for this simulation, this is good enough, okay? So make sure the Cartesian velocity component is set to automatic, the static pressure automatic, the turbulence is to medium intensity, which is equal to 5%, and the smoke is set to automatic, all right? Just click OK. Now, let's go to our solver control. We can double click here, or we can go here in solver control. And here we're only gonna change one thing, which is the max iterations, okay? We're gonna change it from 100 to 75 because we want a faster simulation, all right? So type OK. So basically the steady state simulation is done. This is the steady state simulation. So now we're gonna be working, we're gonna create our transient simulation, all right? So what you're gonna do here is you're going to duplicate the steady state analysis right here. So right click it and select duplicate. So now we have this simulation right here, which is labeled copy of steady state analysis, okay? We're gonna change its name to transient analysis, okay? Because it's displayed in alphabetic order, the transient analysis is going to the bottom right here. All right, so now we're gonna make a few changes to this simulation. Okay, the first is we're gonna make this a transient simulation. So how do we do this? We go here in analysis type, right click it, select edit, and we change it from steady state to transient. All right, so the total time of the simulation is gonna be 30 seconds, and the time steps is gonna be 4 times 0.25, comma 2 times 0.5, comma 2 times 1, comma, and 13 times 2. Okay, so what this means is the first 4 time steps is gonna be run with a time step of 0.25 seconds. Then this is actually supposed to be 2 and times 0.5, yeah. And then we're gonna have the other 2 time steps running at 0.5. Then we're gonna have the next 2 time steps run at 1 second, and the next 13 time steps will be run at 2 seconds at a time. So if you do 4 times 25 plus 2 times 0.5 plus 2 times 1 plus 13 times 2, you're gonna see that the result is 30, which is the 30 seconds of total time. All right, and the simulation is going to start at 0. Okay, so with this being set up, we're going to select OK. Okay, so now we're going to modify one of these boundary conditions right here. So the only boundary condition that needs altering for the transient analysis is the event boundary condition. Okay, in the steady state calculation, this boundary had a small amount of air flowing through it, but no smoke. All right, in the transient simulation, we're going to increase the passage of air through the vent, and there is going to be a time-dependent concentration of smoke in the air. All right, the smoke concentration is going to be initially 0, but builds up to a larger value. The smoke concentration will be specified using the CFX expression language. All right, so let's modify the boundary conditions. Okay, first let's choose the circumvent boundary condition. Okay, now we're gonna change it, sorry, not the circumvent, the vent, because we're only changing the chimney. Okay, so we're gonna change the value from 0.01 that comes from the steady state simulation to 0.2. Okay, so it's much larger, it's more than 10 times larger. All right, so this is basically what we're gonna do for this simulation here. Okay, so select OK. Actually, to make it easier, leave this open for now. So go back to outline, and now we're gonna insert our expressions. Okay, how you do this? You can go to insert, expressions, functions and variables, and expression, or you can come here in expression, right click it and insert expression. Okay, the name of this one is gonna be time constant. I would like you guys to pay attention to how you're gonna name these expressions, because they're gonna be very important, because we're gonna refer to them later on. All right, so the time constant here is 3 seconds. Make sure you type everything that I'm typing here, because now we need to insert the units to the software. All right, so there we go, we have created our first expression. Okay, now let's create 2 more expressions here. So click here, right click here, insert expression, type final concentration, and choose and type 1 kilograms per meter cubic. Okay, So we have 2 concentrations now. Now let's create the proper function that we're gonna insert in the chimney, which is gonna be the exp function. Okay, so it's an exponential function. All right. Now this expression is a little bit more complicated, but I'm gonna go with very slowly for you guys to understand. All right. So the first thing you're gonna do is you're gonna right click it and you're gonna have all of these options, and you're gonna choose expressions and you're gonna choose final concentration. All right. Now you're gonna go here and put an asterisk, which is basically the time signal, and then you're gonna right click it again. You're gonna go to functions, cell, and again then you're gonna find the ABS function. All right. Now we're gonna type 1 minus, right click it, again go to function, cell, find the exponential function, which is gonna already put as the parentheses for us, this like the absolute function did, and then you're gonna type minus t, which t is the variable for time, is the default value for time. Then we're gonna put here the divided signal, which here the program can read. Then you're gonna right click it, you're gonna go to functions, user, you're gonna go to expressions, and you're gonna select time constant. Okay, so this is the function, this is the expression that you wanna have right here. Okay, the absolute function here basically takes the modulus or magnitude of the argument. All right, so even though this expression here can never be less than 0, the ABS function, the absolute function, is included here, is going to ensure that the numerical error in evaluating it near to 0 will never make the expression evaluate to a negative number. Okay, this is basically a trick to make the simulation go smoother. All right, and now click apply. Always remember to click apply after you type your expression, and make sure you have these 3 expressions right here. Okay, very good. Now let's plot this expression. Okay, we're gonna check the time, so we want to see this over the length of time, and the total time is 30, and select plot expression. So we can see that we're gonna have an increase of smoke in our simulation, which is like almost at around 10 seconds reaches its asymptote. Okay, so this is so you know, how the smoke is gonna be inserted in the chimney. Okay, so how it's gonna behave. All right, very well. Let's go back to the boundary, to the vent boundary condition, and let's go here. Instead of using a value, we're gonna use the expression that we just created, which is the exp function. Okay, so now the smoke value is dictated by this expression that we just created. All right, you can click apply, and then you can click OK. Now the initialization values for the transient simulation, they are a bit different. Okay, so when the transient analysis run, the initial values to the CFX solver will be taken from the results of the steady state analysis run. All right, the steady state and the transient analysis will be sequenced by setting up the configurations of this analysis in a subsequent step. For the moment, you can leave all of the initialization data set for transient analysis in automatic, and the initial values will be read automatically from the steady state analysis results. Therefore, there's no need to revisit the initialization settings. Okay, but we do need to change our solver control. So let's double click solver control, and let's change the max coefficient loops to 3. So this is gonna give the software basically 3 tries to converge a single transient loop. Okay, you can leave everything else the way it is and click OK. Now let's set up our output control. Okay, this is done so that to enable the results to be viewed at a different time steps, it is necessary to create transient results file at specified times. Okay, if you don't do this, you're only going to be able to see the results from the last time step. Okay, so, and also the transient results files do not need to contain the solution from all the data. Okay, so in this step we're going to create minimal transient results files. So go to output control, right click it, edit, go to transient results, create a new one. You can leave the name as it is, transient results 1, change standard to selected variables, and then we're gonna choose 3 variables right here. Okay, and you're gonna click the ellipsis button, and we're gonna select the pressure, velocity, and smoke variables. So you're gonna look for pressure, and then you're gonna hold the left control key, you're gonna select velocity, and still holding the left control key, you're gonna select smoke. Okay, so now we're gonna save only these 3 variables here, and we're gonna say that we want them saved at the first, where is the comma in my keyboard? Wait a minute. I'm not being able. Okay, so let me just do this. I'm typing in my Is my comma key broken? Oh no, I'm a dummy. This we need to change first. Like, if we were using a time step interval, basically, if, let's say we type 2 here, this means that the software is gonna save the results every 2 time steps. Okay, but this is not what we want right here. We want a time list. So basically, we want the software to save all the data from pressure, velocity, smoke in the first time step, in the second time step, and in the third time step. Okay, so we know that these values are gonna be saved for the first, second, and third time step. Okay, so click apply, and let's create yet another transient result. So click the blank sheet. The name you can leave the same. Again, the variables are the same: pressure, left control key, velocity, and smoke. But now we are going to use the time interval, because now we want it to be saved for 4 time steps at a time. Okay, so we're gonna change the time interval to 4, and we're gonna click apply. Okay, so what we have here, we have that our results are gonna be saved at the first second, second, and the third second, and after that they're gonna be saved 4 seconds at a time. So we're gonna have results for the first, second, and third second, and then we're gonna have for the 4th second, and then we're gonna have for the 8th second, the 12th second, the 16th second, and so on and so forth until we reach 30 seconds. Okay, so click apply and then OK. Now let's configure the simulation control, which is basically we telling the software to run the static state simulation first, and then using its results for the transient simulation. Okay, so you go here, make sure simulation control is expanded, right click, configuration, insert configuration. Okay, name it steady states. All right, now what you're gonna do here is gonna make sure that the steady state analysis is selected and that the start of simulation option is chosen. Okay, now click OK, and you can see that we have our first configuration. All right, now let's create the transient configuration. All right, so do the same thing. Right click configuration, insert configuration, and name it transient analysis. Okay. Now make sure that instead of steady state analysis, you are choosing transient analysis. The start of simulation is not the one that you want the end of configuration. And at the end of which configuration? At the end of the steady state configuration. Okay, so make sure that this is set up. Go to run definition, select configuration execution control, and at initial values, check here and choose configuration results and make sure that the steady state one is selected. Okay, so here in run definition, all you need to do is actually don't need this. Yeah, you need this. You need this so you open the initial values tab. Okay, and then click OK. Now you can see that all the errors that were in the message box have disappeared. The errors and warnings, okay? This is the only one left because we are using the default domain option, okay? So now let's write our input file. For this, you go to simulation control, right click it and select write solver input file. Okay, you can leave the name the same. Make sure that the file is cfx solver input file, which is .mdf, mdef, and the name I'm gonna leave circvent .mdf. Okay, now you can quit cfx-pre by saving as well. And now let's set up our solution. So go here to Solver Manager, click here, File, Define Run, or you can just click the blank sheet right here. And he's going to ask us to select which solver input file is the one that we're going to use, which is basically the one that we just created. All right. So select it and make sure that the edit configuration is global settings, and basically you can just start your run. What you're gonna see is that we have this little window here that we didn't have before, which is now telling us that this simulation is running and the steady state _001 is in progress. So we go here and there you go. This is the steady state simulation that is gonna be run first, and which we're gonna take the results from. All right. So the first image that you guys are gonna send me is this one. Okay, the one where the steady state simulation has been completed and has been converged. Okay. All right. Now that the steady state simulation is done, we can monitor the transient one, which is this one. Okay, and you can see that these values right here, they are a little bit different because the transient simulations are done by coefficient loops. Remember that in the pre-phase, we changed from 10 coefficient loops to only 3 to speed up this process right here. So this is basically what we did, okay? So this is the second image that I want you guys to send me, so I know that you've done the transient simulation. The third one is this right here, because I want to see that you have done the simulation and that you have all the 2 steps right here. Okay, so after this is done, you can go to Tools, post-process results, mark shutdown CFX over, and click OK. Okay? Now let's see our results. There you go. We have our atmosphere and our chimney. Let's go to predefined camera Z up. And now let's see how the smoke is behaving in the last time step. Okay? How you do this? Let's create an isosurface. An isosurface is basically a surface of constant value for a variable. Okay? For example, you could set up a surface consisting of all points where the velocity is, I don't know, 3 meters per second to your problem, okay? But for this case, we're going to create an isosurface of smoke concentration, all right? From the additional variable smoke that we set up earlier. So what we do here is we go insert location isosurface, or we click location and select isosurface, all right? The name you can leave the default. The domain is all domains, change the variable to smoke all the way to the bottom. Okay, usually it's gonna come like this. Just scroll down and find smoke. All right, the value that we want to see is 0.005. okay, and click apply. There you go. You can see the smoke coming out of the chimney right here, and you might look at this and you say, this is a very, I don't know, bumpy smoke visualization. This doesn't seem correct. And you would be right. You know why this is so bumpy? Because the mesh is very, very coarse. So if you wanted this to be more closer to the reality of how a smoke is dispersed, we would need to change our mesh to a more refined one. But this is only for me to showcase some functions of the software and not the importance of a mesh, which by now I hope that you already have a basic understanding of how important a mesh can be from our last 2 lectures. Okay? So now let's change this variable to 0.002. See? Because we reduce the concentration, we have more area where the smoke is So you can even like do something like this, and the higher the concentration value that you put, naturally the closer it's gonna be to the vent, to the chimney. Okay? But you can play around with this value to see how it changes, but let's choose a variable of 0.002 and make sure that our predefined camera is Z up. Okay? Now, because we ran a transient simulation, a time-dependent simulation, we can see the position of the smoke at different times. And how we do this? It's very, very simple. Go here to the time step selector, and by default, the software puts us at the last time step. So you can see where we have values, okay? We have values at 0, 1, 2, 3, 4 seconds, and then we have at 8, 12, 16, 20, 24, 28, and 30, which is how we set up our output control, okay? And you can see, like, if you select the time step and click apply, the smoke changes, because at 2 seconds, the smoke had not yet reached this wall, all right? If you go back to 30, you can see that smoke have already propagated more. If you go to 12, it's in the middle. If you go to 20, it's already in the wall, okay? And you can play around and see how the smoke changes in all time steps, okay? So let's go back to predefined camera Z up, and this value at 12 is gonna be the fourth image that I want from you guys, okay? This image right here, okay? So you can leave the time step selected at 12, okay? Actually, don't send me this image that I sent you. Send me this image that we're gonna do right now, because we're gonna create a title for this image. Okay? How you do this? You go to Insert, Text, and then you can leave the default name. And this text string that I want from you guys is this one. I already have it written here. I want this title from you guys. Isosurface showing smoke concentration of 0.002 kilograms per meter cubic after. And you leave this blank space after here, okay? Because further text will be added at a later stage to complete this title, okay? Now check embed auto annotation, and you can already see that they put this little text here, because this is gonna be the auto text that is gonna be shown there, okay? Change expression to time value and create apply. And there you go. You can see that the title is showing up here, and this value is auto-generated. So if you come here, oops, not here, here, and we select, for example, 30, you can see that's gonna change. If you select 3, it's gonna change again, okay? So I want this image from you guys, okay? The image at smoke at 12 seconds with the title, all right? Very well. Now, actually, I'm gonna show you for you guys, so you don't have to print screen. I'm gonna show you how you can extract an image from the software. You can do this by going here in the little camera box, save picture, and then you can select whatever the folder that you want and the name that you want, and you can also select the files, the type file. Just so I know that you guys are doing this, I'm gonna want you guys to change from the default one, from the PNG to JPEG, okay? And I also want the background to be white, all right? And so I can better see the lines, I want you guys to change the wireframe. So go here, double click wireframe and change line width from 1 to 5. So now the lines of our domain are thicker and we can actually see it better. So go back to picture, change the file type to JPEG, the format to JPEG, whatever the name you guys want, that is not a problem. And then go here, change it to 500 so the quality of your image is better, and then select save, okay? So now you're gonna have an image saved from this image right here, okay? From this one. You can actually see mine right here. See? I want to show you guys, if we didn't change the wireframe, how this would look, okay? So pay attention that we can see the lines of our domain very clearly, right? If we go back to our software and go back to the line width of 1 and save it with the same simulation, with same characteristics, you're gonna see a very clear difference, okay? See how much dimmer they are and how harder it is to see? So this is why we changed the wireframe to 5, so that our generated images are better, okay? So let's go back to 5. There you go. Now, the last thing that we're gonna do here is create a movie of the smoke coming out of actually the second to last thing. We're gonna do one more thing after this. We're gonna create a movie of the smoke leaving the chimney, the vent, okay? So how you do this, you go to the time step selector right here, the animation, I'm sorry, not the time step selector, the animation box right here, click it, and then go to time step. Make sure that it's controlled by time step. Make sure that you have this right here expanded. Check save movie. Okay. Also, make sure that you're in the first time step. You can do this by either moving this bar right here, or let's say you are at the 12th time step as we were. You can click in the time step selector in the little clock, go to 0, and now we're all the way back to 0. Okay, make sure that the camera is Z up. You can change the name of your movie, and I want you guys to also change the format to MPEG-1. Okay, save, and all you need to do now is make sure that this is checked. All right, so you guys are actually saving the movie, and you can click the play button. There you go. Now we have the animation of the smoke coming out of the chimney. All right, and we have the movie right here. Let's open with the VLC media. Thank you very much. There you go. Now we have the smoke coming out of the chimney, and you can also see that the title is also changing according to the time. The title is also changing according to the time. Okay. Now let's do one last thing, which is we're gonna load only the last result of the simulation, so we can generate an image faster. Okay, so by the way, I want you guys to send me this file of this movie as well. Okay, so let's do one last thing. Okay, let's go to here, file, load results, and we're gonna select this one, circvent_001.mres, m results. Okay, make sure that this is selected. Load only the last results. Okay, and click open. You can click proceed in this warning. Okay, now make sure that the isometric view, that the camera is set to isometric view Z up. Uncheck the title and the isosurface, and now we're gonna create a volume rendering, which is actually gonna create that more style look, that more smoky look that we're looking for. This is very good for example, if you're doing a presentation or you want to show this to a client. It's gonna be the images that we set up before. They are extremely valuable from a technical standpoint, and this one is more valuable for a showcase standpoint, which both are very important. Okay, so what you're gonna do here is gonna go to insert volume rendering, or you're gonna just click volume rendering right here. Okay, the name is gonna be smoke volume. There you go. Now the variable is gonna be smoke. Okay, the resolution we're gonna leave at 20, and the transparency we're gonna leave at 0.2. Okay, but the color map we're gonna change. Instead of rainbow, we're gonna use a grayscale, because we're dealing with smoke. Smoke is not colored. Okay, the smoke from a chimney is not colored. So type OK, and there you go. You can see that is much more of a smoky look. All right, you can actually play around with this little bar here. For example, you can do this, and you can see that it's become darker. The smoke has become darker. You can increase the resolution as well. For example, let's change it to 50, and you can see that is much more darker as well, because we increased how much more smoke we can see. Okay, but I would recommend you guys to choose 20 resolution and 0.2 smoke, and I want this file from you guys, but I don't want a print screen from this. I want you guys to send me a very high quality picture like I showed you guys before. Okay, oops, let's change the name to, so we don't erase the other one. And you can see, because the volume render is selected, it takes a little bit more time, because these are more dense variable that we're choosing to show. We're not showing a surface, right? We're showing a volume here. So we have the software needs to save more information. So we have it here, and there you go. Our beautiful smoke coming out of our beautiful chimney, coming out of our beautiful domain. All right, guys. So basically what I want from you guys is 3 images from the Solver Manager, the one showing the convergence from the static simulation, the one showing the convergence from the transient simulation, and the one that shows the tree line of the 3 simulations, which I showed you guys while I was doing it. Then I want this image, whoops, this image, yeah, but with the wireframe selected to 5, the line width of the wireframe selected to 5, and then I want, where it is, where's the movie? Did I save the movie here? Well, I want you guys to send me the movie as well, remember? I might have deleted, I don't know. And I want this image as well, okay? So I want you guys to send me all of these images, all right? Hold on, I think I need to do this and this. Yeah, there we go. And I want you guys to send me this file as well, okay? So I hope you guys enjoyed this lecture. Have a great time, and see you guys next lecture, okay?